percentages, and we're going to make it really easy to understand. So a lot of people are scared of percentages, but they're really, really useful, especially like if you're doing chemistry, physics, accounting. It doesn't matter what you're doing. Percentages help you understand relationships between things, rates, rates of change. Percent triangle is a little tool that we're going to learn about right now. So we're going to go to draw, and we're going to show you the percent triangle. So a percent triangle is a simple little tool that you can have in the back of your mind. You say, well, if I have part of something, I'm going to divide that by the whole in order to get the percentage. If I have part of something, I can divide that by the percentage, which of course will convert to a decimal, and we'll talk about that, in order to get the whole. If I have the whole of something, I can multiply that by the percentage to get the part, so on and so forth. So let's talk about the whole, part, percent, and then they're forgetting we need to call percent decimal and ratio as well. So let's clear this out. So if we have 1/4, we know that this is equal to 0.25, which is equal to 25%, which is equal to 1/4. Okay? So we have 1 out of 4. 1 out of 4. 1 is the numerator, 4 is the denominator. This line right here, it tells us to divide, so it's also equal to 1 divided by 4. It's one of those rare instances where we go from right to left here. So 1 divided by 4. So we can say, how do we know that that's 0.25? Because right over here, we just say, how many times is 4 going to 1? Well, it doesn't, so we have to draw a decimal right here. Bring that decimal up here, and then we draw a 0, and we pretend that 1 is now a 10. You say, well, how many times can 4 go into 10? Well, 4 can go into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. 4 can't go into 2, but we're going to draw a 0, and we're going to drop that 0 down, and 4 can go into 20, and it can do it 5 times. Now if we multiply, so before we went that 2 times the 4, and we got the 8. Now we're going to go 5 times the 4, and we'll get the 20, so it'll be 20 minus 20, and it'll 0 out, so 0.25. Now how do we know that 0.25 is the same as 25%? Because we simply move the decimal 2 places to the right, and that gives us our percent. Likewise, if we have a percent, we move the decimal 2 places to the left, so just the inverse. So 1:4 just says a ratio of 1 per 4, which is what we see we have. So that's how we make all those calculations. Really, really easy. We have something called improper fractions or top-heavy fractions. So if we said like 5/3. 5/3 is equal to, as we established over here, 5 divided by 3. So 3 goes into 5 one time. 1 times 3 is 3, right? Because we're going to multiply that 1 times 3, and that equals 3. 5 minus 3 now is 2, as we know. So 1 2/3 is our solution. So 5/3 is equal to 1 2/3. This is just a non-top-heavy form of the same thing. So this is letting us know we have one whole, so we have 100% plus 2/3. 2/3 is going to be what, 33.33%? So we have 133.3%. You might say, well, how can I have more than 100% of something? Well, let's just imagine a football team. A football team is allowed to have 11 men on offense, 11 men on defense. So let's say they have 22 spots for players, but they employ 2 or 3 extra players just in case someone gets hurt. So their roster is sitting at over 100% manpower. So that's an example of how you might use that. So, again, 5/3 is the same as 133% or 1 2/3. So the way we get this into 133% is we'd simply divide here, 2 into 3, and that would give us our percentage that we need to adjust that to 133%. So you see that fractions, decimals, percents, and ratios are all in division, are all the same thing. It's just different ways of representing or describing something, or the relationship or rate of something to something else. And that's it. Oh, and don't forget that percent triangle. So if you say, I have this x part of something, the of something is the whole, right? The part is right here, and then the percent can be calculated by just following these rules, or the whole of, if you're given the percent and the part, you can isolate what the whole is. You can just use this percent triangle to solve any of these problems that you would need to identify. And just remember when dealing with ratios that the first number written is the same as your numerator, and the second number written is the same as your denominator.